Here we like to find out the infinite sum of the geometric sequence. We know if we add the first n terms together, then the formula would be like this, which is the initial term, or the first term, times 1 minus ratio to the nth power divided by 1 minus ratio. We know that a1, the first term, is you substitute 1 for k, you will find out a1. So 4 times 2/3 to the here k from 1. So you put 1 minus 1 here on the exponent, that's 0. 2/3 to the 0 is 1, not 0. Any number to the 0 is 1. So you have a 1 is actually 4. Now, a 2, of course, replace k with 2. In order to find out ratio r, really we need is the ratio of the first two terms. The second term divided by the first term will be the ratio. So we know a2, you plug in 2 here, 2 minus 1. And a1 here, you plug in 1 here, 1 minus 1. Then what we have will be 4 times 2/3 to the 2 minus 1, which gives us 1. Again, 1 minus 1 for a1, then gives us 0. 4 and 4 are cancelled. So we have a denominator is 2/3 to the 0 again. Any number to the 0 is 1. And the 2/3 to the first power is just 2/3. Okay, so we have r is 2/3. Now, in this formula, we have a1 for r 2/3. Then we know when the r is replaced by 2/3, we know when n gets bigger, 2/3 to the n will be very small. Again, you may try it. For example, if here, let's turn on the calculator, you have a 2/3 here, you may calculate the fifth power. That's very small, 0.13 something. If you do 2/3, let's say the exponent may be 15. You see the number is getting smaller, 0.00. It's getting very close to 0. Then you do 2 divided by 3. You may do maybe 55. That will be 10 zeros before 2. So this number is very small. Okay, so if you put like 2/3 to the 100, that's really going to be small. You may try that. Let's say 2 divided by 3. You may try 100. So you see there are 18 zeros before 2, very close to 0. So then you know when n goes to infinity, this number can be ignored. So this number can be ignored. And then for the infinite sequence, basically we do not need minus n to the r, minus r to the nth power. It's just this number. Initial term times 1 over 1 minus r without even calculating that. That's much convenient. Initial term is 4 times 1 over 1 minus ratio is 2/3. Ratio is 2/3. And 1 minus 2/3 is 1/3. So 4 times 1 over 1/3 is 12. Because, 1 divided by 1/3 is 1 times 3 over 1. And that's 3. 3 times 4 is 12. Okay? So the sum of this sequence indeed is 12. That's it. All right. Remember, for the infinite term, when you choose the sum, you only need first term and the ratio. You do not have to worry about n. Okay? All right. See you next time.